I realize I forgot to mention how office hours will work. So basically, I'll hold office hours here in the classroom. I'll just get here maybe 30 to 45 minutes early each week. So I'll get here between around 6:15, and if you're here and if you have questions, I'm happy to answer them. Okay, so that's each week before class. You just get here a little early, and I can help you out if you have questions. You can always email me if you're still confused about something, and we've got that. Okay, so we'll continue on. While we are talking about categorical variables, okay, so this is the same data table from before. You don't have to rewrite it in your notes, but this is just so there's some context here. We can talk about visualizing our categorical data. So I'm skipping a few sections in the textbook to this is visualizing categorical data. And this is section 2.3 in the text, and you have a few problems in your homework related to this. So we'll talk about this, and then I'll go back and finish the last section in chapter 1, which is about studies and experiments and cause and effect. Okay, so with visualizing categorical data, we can one way we can present the data is with bar charts, okay? And so with bar charts, essentially what we do is we take, a column, and so let's say we create a frequency table for sex, and what do I have? I've got male and I have female. And so how many males total do I have in my data table? 5 and 2 females, right? So with a bar chart, all I do is I create a bar for males and I create a bar for females, and I have a vertical axis showing the count or frequency, depending on what word they use. And this would be numbered to show how many people. And so for the males, I would draw a bar that goes up to 5. And for the females, I would draw a bar that goes up to 2. Okay, and there you have, this would be a bar chart, okay? Now I don't need to write that. So we have that right there. Straightforward enough, okay? The thing about bar charts, a few things to note. One, the ordering of the bars is arbitrary. So here I have males on the left and females on the right. I could just as equally switch them around, and the bar chart is just as valid. Okay, you might have 6 categories. If we're talking about hair color, okay, you could have black hair, brown hair, blonde hair, red hair, other colored hair, things like that, and the ordering of the bars don't matter. Okay, common ways to order bars is that you can arrange the bars in depending on the counts. So these are, these are options that you can do. Arrange bars according to the counts of the bars. Or, arrange the bars based on alphabetical labeling of the categories, right? You maybe arrange the bars based on the category. So like in, for example, in alphabetical order or something like that. Or maybe there is kind of a natural ordering of categories. Maybe you have something like small, medium, large, extra large. Maybe there's already a quote-unquote natural ordering of the categories. For example, small, medium, large, extra large, or something like that. So there might be a natural order to the categories. But the truth is any arrangement is valid for a bar chart. Okay? It's very important that we have the count on the vertical axis, or if not a count, a percentage, okay? Or a percentage for the vertical axis. Okay, so those are bar charts. And just traditionally, we leave a gap between the bars, okay? It's not wrong per se to have no gap, but it just doesn't feel quite right. Right? So these are bar charts, and you can have multiple categories, things like that. Is that okay? There's also here, actually, let's go back. You can also turn pie charts, make pie charts, but I don't really like pie charts, so I'm just gonna make one and say I don't like them. What is? Because with pie charts, I have to do something like 5 divided by 7 is 0.714, and I have to multiply it by 360 and say 257 degrees. So that's like something like this. I have no idea. Okay. And I would write male, and I have female, or something like that. These are less preferred, and they only really show up in like PowerPoint presentations, pie charts. So don't use them. A bar chart is almost any situation where you can use a pie chart, you can use a bar chart, and almost always a bar chart will be a better tool for presentation. Our eyes are good at detecting differences between bars. They're terrible at detecting differences between slices of pie. Like, for example, if well, this is a crappy circle, but how do you draw a circle? It's really hard. If I said which slice of pie is bigger, I guess this one. I don't, and by how much? It's a little bit tricky, okay? But if I draw two bars, and I've got this one over here, and this one right here, your eyes can very easily tell that this one is shorter than this one. Okay, your eyes are very good at detecting height differences or things like that. They're really bad at angled, if I had another pie over here, which slice, arrange these 3 slices in order from largest to smallest, you couldn't do it. But over here, if I do this, these are very close together, but your eyes can see these things. So almost always bar charts better than pie charts. Anyway. So we have that, okay? That doesn't matter, okay. But now you know, okay? So next time PowerPoint gives you the option to make a 3D pie chart, say no thank you, I'm going to make a bar chart, okay? Yeah, the 3D pie charts are the worst too. You got this thing, and you got and then it's like this, these are people that ride bicycles, and these are people that, that ride the bus, and it's like, what are you trying to say here? Is okay, all right, anyway. The point of graphs is to communicate information. You don't want to confuse the people, that's right? It's not to look pretty, okay? If we wanted things to look pretty, we would just photograph pretty things. With the usefulness of a chart is its ability to convey information, okay? So have a chart that's useful, put in a pretty picture next to it if you want something pretty. Don't try to make the chart pretty by making it useless. I want to talk about variation, okay? Variation in categorical data. Okay, so next week we'll talk about numeric data. This week we're talking about categorical data. All right. Just a quick quiz verbally. How do we summarize categorical data? Counts and percentages. Okay, good. That's how we summarize categorical data, okay, with counts and percentages. Next week we'll talk about summarizing numeric data with means and medians and that kind of stuff. This week we're summarizing categorical data with counts and percentages. We can also talk about variation in categorical data, okay? So what is variation? Yeah, variation means things are different, right? Everybody here is different from one another, and depending on where you go, there may be more or less variation in the people you meet. Okay, in Los Angeles, we would say we're a diverse place, right? We've got people with all sorts of backgrounds and economic levels and things like that. If you go to Japan, you have less variation, okay? Pretty much every person in Japan, not everybody, but the vast majority are Japanese people, okay? No surprise there, right? And you come to America, you've got much more diverse things. So we've got variation, and that would be, just talking about, people, and other things. Maybe if we were to look at people's weight, okay, the how much someone weighs, you'll see different amounts of variation. So let's say, okay, let's say we looked at cheerleaders for the NFL, and we looked at how much each of these cheerleaders weigh, okay, versus, let's say we go to the Olympics, okay, and we see how much the different Olympic athletes weigh, okay. We're going to see a lot more variation in the weight of Olympic athletes, right? Because we've got gymnasts who are, or at least the female gymnasts are very small and probably, weigh, I don't know, 100 pounds or something like that. And then you've got the hammer throw people that are very strong, and I don't know what other things, you got different, a wide variety of people, right? If you look at, what did I say, cheerleaders or something? Nothing against cheerleaders, but they all probably not look alike, but in terms of body types and how much they weigh, they all probably fit a certain, quote, stereotype, and so you're not going to see as much variation there, okay? So we can think of variation for numeric variables, and we can think of variation for categorical variables. So today we're talking about variation in categorical data. So I've got a question here. Okay, I'm going to show you, let's say I've got 2 classrooms, okay? And we just asked the gender, okay? And so one classroom looks like this. We've got males and females, and I don't know. 10, 20, 30, 40, 50, 60, 70, 80. So this is 80. And all right, so this is not very well labeled. Okay, so this is one classroom. And another classroom. Looks like this. Okay. And we'll say this is 50. Okay, so these are just, I don't know, counts. Well, they could be percentages because they add up to 100. But okay, so these are 2 classrooms. There's 100 people over here, and we'll say 100 people over here. And we'll call this classroom A, and this is classroom B. Okay, which classroom has more variation? The answer is classroom B has more variation. Just visualize these classrooms in your head, right? Okay, so classroom B, with regard to gender, has more variation. Okay, because if visualize classroom A, you look around, you are surrounded by what? Men. Okay. There's a few females in the class, but pretty much you're looking around and you're like, there's a bunch of guys here, okay? Classroom B, you look around and you've got a good mix of men and women, okay, males and females. And so in this case, okay, there is more variation, more, quote, diversity with regard to gender, okay? Does that make sense? Okay, so, and you can think about, and this could be applied to, let's say, you had categories for ethnicity, okay? Excuse me, now I've got the coughing fit. Let's say we go to Utah, okay? Nothing against Utah, but just demographically, Utah is different from, let's say, Los Angeles, right? And so this would probably be white people in Utah, and yeah, let's just have let's see. Now I'm gonna. Okay, I don't want to get in trouble on here. Okay, so here's.
I'll say it for you.
Yeah. Okay. So let's say Let's say we have different races here. Okay. So we got white, black or African American. Let's say Asian and Hispanic or Latino. And then and anybody who doesn't fit any of those categories, we'll just leave it as other. Okay, and then so you go to Utah, it probably will look something like this. Okay, maybe not. Okay, and then you come over to let's say Los Angeles, and and I'm just going to do this. It probably is more okay, something like this. Okay, I'm just don't quote me on these bar sizes, but you know, if we imagine, you know, which place is more diverse, Los Angeles or Utah, I think we would say LA, right? At least when it comes to racial diversity. And that's, you know, if you think about it, you know, you got in Utah, you probably have one category that's in terms of frequency or percentage much more dominant or prominent than the other categories, whereas Los Angeles, they're kind of more balanced out per se. Okay, so that's that. Regarding in categorical data, if there is a category that seems to be the tallest category or the most dominant category, this is known as the mode. Okay, the mode is the category with the highest count. So in classroom A, males would be the mode. Classroom B, there would be no mode. Okay? So over here we have no mode, and we would have mode male. Okay? Utah, mode would be white. Los Angeles, I actually don't know. I think it's pretty close between Hispanic or Latino and white. I don't know regarding racial diversity. I guess it depends how you define Los Angeles and what is it, Los Angeles County or Los Angeles City or Greater Los Angeles, whatever. Okay, it's all different, but so we have that. Okay, so that's variation in categorical variables. Is that okay? Okay. Variation when it talks to numeric variables is going to be very different, okay? If we're talking about numbers, you know, 50 versus 50 versus 80 and 20, then yeah, 80-20 will have more variation, of course. Okay. All right, let's talk about, let's go back to data collection. This is from Chapter 1, so we're going back to Chapter 1, Section 4. We're going to talk about data collection and cause and effect. Okay. So this concept of cause and effect, this is also known as causality. And it's a tough topic in terms of, you know, if you're trying to understand, you know, what causes the other thing. It's actually rather difficult to figure out. But anyway, let's talk about data collection. We've got a few different types of data, okay? And I'm going to start off with the anecdote, okay? Anecdote/anecdotal data. Okay, anecdotes and anecdotal data, these are stories that your friends tell you, okay? These are kind of like, so it'll be something, and you know, customer testimonials kind of fit under anecdotal data. It'll be like, oh, you know, I know someone who tried this product and it helped her lose a lot of weight, or, you know, I know someone who did this and it, you know, she was suffering arthritis and she did this thing and her arthritis went away. And you're like, oh, well, that's cool. You know, should I go spend, you know, this money trying this thing out? And the answer is maybe, maybe not. The thing that you're talking about may actually be effective, or it may not be effective. But one person's story is not enough for us to say, therefore this works, okay? So, you know, just because it worked for one person or even a few people doesn't necessarily mean it'll work for everyone. Doesn't necessarily mean it's more effective than a placebo, okay? So I'll put that here, okay? So just because something works for one person or a few people, or does not mean okay. At the same time, it does not mean that it's not effective, okay? Just because maybe you only have anecdotal data for something, anecdotal data doesn't prove something either way. It doesn't mean it is effective or ineffective. It's just you can't do a whole lot with anecdotal data, okay? Other than have these nice stories that are maybe encouraging, but it doesn't necessarily mean it will or will not work, okay? Okay, so I'll say at the same time. So as far as statistics go, the subject of statistics is not able to do much with anecdotal data, okay, or anecdotes. Not to say that they're useless. Anecdotes, I don't want to say that they're useless. It's just in statistics we can't do much with it, okay? So for statistics, okay, we need data either from observational studies or controlled experiments. And what we do is usually in statistics, when we're talking about statistical data, we have something, we start off with a research question, right? Okay. And we've defined something called the population. What is the population? Huh? The population it's not our sample. So we've got the population, we have the sample. So what's the point? Why do we have the population, or what is the population? The population is everyone relevant to our research question. So maybe I'm a pharmaceutical company. Hopefully not an evil one. And let's say, you know, my scientists have come up with a drug, and they say, oh, we think this will help people with diabetes. Okay? So my question is this drug effective in, I don't know, controlling blood sugar for people with diabetes? Who would the population be? Yeah, it would be everyone with diabetes, okay? It'd be everyone with diabetes would be my population, okay? Obviously, I can't study every single person with diabetes, and so hopefully I'm getting a sample of people that I can, is willing to test out the drug, and hopefully these people that test out the drug would be representative of everyone with diabetes, okay? And if the drug is effective on these people in this clinical study, if it turns out to be effective here, then I might be able to say, oh, well, it's effective here. These people represent everyone with diabetes. Therefore, I'm going to conclude that this drug would also be effective to everyone with diabetes, okay? Obviously, I'm not going to say, well, the conclusion's here. Well, it helped these people with diabetes, therefore it's going to help people with cancer or something like that, right? So you have to think about, what is your research question? What are you asking? Who are the people relevant to that research question? That would be your population. Okay, and the sample, okay, we can't study everyone, so the sample are the people from the population that we can study. To answer our research question, we have what we call a response variable. Okay, this is the outcome or the variable relevant to our research question. Okay, the outcome variable. That will, I guess that is related to our research question. So with my diabetic drug medicine, or diabetes medicine, the response variable, because my research question was, is this drug effective in controlling blood sugar for diabetic patients? The response variable would be, for each individual person, is did it control blood sugar or not? Okay, so that would, that's a very simplified outcome, but that's essentially what we want to know, right? Did this drug work for controlling blood sugar, or it didn't work? Okay, so our response would be it worked or it didn't work, or it controlled blood sugar or it didn't. If you're asking something else, does drinking milk help children grow taller? Okay, we think the answer is yes. But if we wanted to do a study, we could the response variable would be how tall is the child, or how much did they grow, or something like that. Okay, that's how we would try to answer this question. Okay, so that's the response variable. And then the thing that we can kind of change or see if it has an effect, that's known as the treatment variable. Okay, this is the variable that we are interested in to see if it has an effect on the response variable. Okay, so this is the variable that we want to know. If it is related to the response. Sorry, this sentence isn't the best English there, but I hope you understand what I'm trying to get at. Okay, whether someone takes the drug or not, we want to know if that has an effect on blood sugar. Whether a kid drinks milk or not, does that have an effect on how tall they grow? Okay, these are the types of things that we're trying to answer with data, and we parse the answer with statistics. Okay. So when we go out and gather data, either through an observational study or a controlled experiment, what we do and how things work are a little different. Okay. Can I go on to the next slide? Okay, so in an observational study, okay, we do not interfere with the subjects we study. Other than taking measurements. Okay, so in an observational study, we don't interfere with the subjects other than taking measurements. And with an observational study, the best we can do, the best conclusion we can make is that two things are associated. Okay, we cannot make cause and effect conclusions from an observational study. Okay, and that is because we are not interfering with the subjects. So people choose what they want to choose, and then we see what happens. Okay, so here is, so for example, there is a study, like, does listening, having your baby listen to music while you're pregnant, does that make them smarter or something like that? I don't know. Have you guys heard of stuff like this, right? And you wonder, like, okay, well, if you have your, if you're, I'm like pretending to be pregnant here, but, if you're a woman who's pregnant and, you, I don't know, put speakers next to your belly while you're pregnant and you have your baby listen to music, does this help develop the brain of your baby? Okay, well, they did some, I don't know what kind of research has been done, but if this was just an observational study, we cannot conclude that the music helps make the baby smarter. Okay, even if the data seems to support that, even if the data shows that we looked at families where they had played music for the womb, in the womb, and families that didn't. So let's say, okay, I'm going to just write this. Does music while pregnant, lead to smarter babies? This is what we want to know. Okay, I don't know. Okay, so let's say our data, we've got music in womb and no music in the womb. All right, not technically in the womb, but okay. And let's say the average, let's say IQ. Let's say we measured the average IQ, and over here it's like 107, and over here it's 98. Okay, and we'll talk about statistical significant, but let's say there is a statistically significant difference. Okay, and we'll talk about what that means much later. Okay. Does this mean that music in the womb causes intelligence? No, why not? Well, it was not. It was not a controlled experiment. Okay, and so let me just turn this into just a very silly example. Let's say somebody said, let's say a study was released that said, if you put your baby in purple pajamas, it'll make them smarter. Okay, and we ask, okay, do purple pajamas lead to smarter babies? Okay, and you know what? At the end of the study, I promise you, if we did a study on, if a study was released on purple pajamas and we did a study at the end, what we'd find is that kids who wore purple pajamas, their IQs will be higher. Okay, maybe let's 106 versus no purple pajamas. Maybe over here, 97 or something like that, okay? Again, statistically significant. Okay, and over here, we can look at this and say, well, that's silly, okay? How can purple pajamas be causing intelligence, okay? And the answer is the purple pajamas don't cause intelligence, increase in intelligence. What's going on is that the parents who are going to stick their kids in purple pajamas are going to be one type of parent versus the parents who don't stick their kids in purple pajamas, okay? And that is going to be the thing that makes a difference on the intelligence of children, okay? So if you've got a parent who's very eager on, following the latest studies and conclusions there, the type of parent who takes an interest in purple pajamas, that is the cause. Or that's probably the reason why children are showing different levels of intelligence. It's not the purple pajamas themselves, okay? And so if all you've done is an observational study, we cannot make these kinds of conclusions. We cannot say one causes the other. Yes?
I might be jumping the gun, but if we go up to the music, say we measured children instead of babies and we gave them an instrument instead of listening, is that no longer observational?
Yeah, so if we're now interfering and if we're saying, hey, you kid, you're going to start playing the piano. You got no choice. We're going to make you play the piano. We're going to make you take lessons, and then we're going to see what happens. Then that's no longer an observational study. We have now interfered with the child, okay? But yeah, if we look across the board and we look at children who play musical instruments versus children who don't play musical instruments, you will see overall children who play musical instruments to be of higher intelligence, or higher, maybe intelligence isn't the right word, but just say will have better academic performance than children who don't play instruments, okay? If we just do an observational study. And that's because, in general, families that can afford to have kids play a musical instrument generally have more resources for education and things like that, and will therefore the child benefits in terms of academic performance, okay? So, if we look across the board, what we generally find is that families with high income have children performing academically better than families with low income. Does that mean money is the cause between, it's very complicated, okay? What causes differences in academic performance? That's a very complicated answer. We find that it's connected and associated with a lot of things, but these are all observational studies, and so we can't say one thing causes another. All right? And so a lot of studies, you'll see a lot of studies released, and like Facebook, people like to share these, studies that have interesting things, and they say, well, this and this happens, and don't drink soda because it's gonna do this, or don't do this because whatever. This study was released and its findings will blow your mind, or whatever. If it's an observational study, we cannot make cause and effect conclusions. That's the rule, okay? Because a lot of these things, we have what we call confounding variables and lurking variables. Yes?
So then what's the point of doing an observational study at all?
Okay, so this is a good question. Why even bother? Well, I'll talk about experiments in a moment here, but so let me just write this thought about confounding and lurking variables. Okay, so there might be other things responsible for the cause and effect that may be so I didn't write it up on the board here, but the point of this thing with the purple pajamas and music while pregnant is that even if the data shows that there's a relationship, that doesn't mean one causes the other. Okay? And so, yeah, why do we bother with observational studies if we can't draw cause and effect conclusions? Well, just knowing that two things are related is useful. Okay, we might not be able to draw cause and effect conclusions, but we might be able to say these two things are related and do the best we can with that. Okay, a lot of times, and I'll talk about experiments in a moment, but a lot of times certain experiments are not possible because of ethical reasons. Okay, in general, it is not ethical to have an experiment where you're expecting something to have a negative effect on a person, right? We can't have an experiment and say, we want to know if daily usage of cocaine has negative effects on your body, okay? And we can't say, oh, well, thanks for volunteering. Here's some cocaine. Please start using it every day for the next 6 weeks, and we'll see how you're doing at the end of it. Okay, that would be unethical. It might provide some interesting insight, but we can't do that. Okay, and so all we can do is look at what has happened to people who chose to use cocaine and see what happens there. But that would just be an observational study. Okay, so for example, so for a long time, the tobacco industry said, does smoking cause cancer? And the tobacco industry would say, oh, well, all the studies so far have just been observational studies, so you can't say they cause cancer. What we've seen is that people who smoke get lung cancer at a much higher frequency than those who don't smoke. Okay, but an argument that the tobacco industry used was these people had a genetic predisposition for lung cancer anyway. Okay, so when people are born, some people are going to form lung cancer no matter what they do, and actually it's that genetic predisposition that causes them to want to start smoking to soothe their lungs, or and it sounds ridiculous, but from a statistical standpoint, it's also difficult to argue against. Okay, after many studies, and you could do cause and effect conclusions on like mice and say, well, we forced these mice to smoke, and they got lung cancer, and then they would come back and say, well, that's mice. Mice are different from people, so you can't say the same applies. I think today they admit that it's bad for your health, but to say one causes the other is actually a difficult thing. Yeah.
Is it unethical to have a willing sample audience?
To an audience who's willing to do things that may cause detriment to them knowingly.
Go to Skid Row and pick up a bunch of drug users.
Yeah. So there is ethics is a whole nother whole nother class or course, and the answer to these things are not clear, right? Is it ethical to allow someone who wants to die? Is that ethical? That's a very complicated question. And so, a lesser degree would be, is it ethical to allow someone willing to incur bodily harm to do that? I don't know. Okay, so we're not going to get to answer those questions in this class. Okay, we're just talking about studies.
Drug trials where you're receiving something that might be harmful, but might help you at the same time.
Yeah. So usually that can be I don't know, justified. So now we're getting into ethics here. Usually it can be justified, right? We can say like these side effects might exist, but also this benefit might also exist, and people are often willing to do that because that's pretty much everything in life, right? Every choice you make could be a good or bad thing, depending on what happens. But so anyway, that's observational studies. Let's talk about experiments, and specifically controlled experiments. In a controlled experiment, what we do is we control as many aspects of variation that could have an effect on the response variable, okay? We try to control as many aspects of variation and so ideally we can separate a representative sample into two groups. The control group and the treatment group. Okay. And ideally, everything about these two groups are as identical as possible. Okay. The only difference between the two groups is that one group gets the treatment and one group gets the control. So for example, one group gets the experimental drug for diabetes and the other group gets a placebo. Okay. So for example, experimental drug versus placebo. And so, so if you're going to do a controlled experiment with the diabetes drug, ideally you would have two groups representative of the population, and you control as much as you can. You would say both groups, you're going to have the same diet. You're going to eat the same things. Both groups, you're going to do the same amount of exercise. Both groups, you're going to get the same amount of sleep. Both groups, you're going to have the same type of work, right? You're going to have the same amount of stress, etc. You're trying to control as much as you can, with the exception, this group, you get the experimental drug. This group, you get the placebo. And at the end of the study, if there is a difference between the two groups, we can say, hey, both of these groups were exactly the same, except this group got the drug, this group got the placebo. Therefore, the difference we observe is due to the drug or the placebo. Okay? That's ideally what we can do. Obviously, we can't do that all the time, right? There aren't very many people who are willing to subject themselves to say, okay, well, I'll have this food and I'll have this life, and I'll let you do all of these experiments type of thing. Okay, so but we try to control as much as we can. Okay, with things like rats and mice, it's easy to control these things. Whether that is ethical or unethical is another question, right? Animal testing, things like that. But with animals, it's easier to control things. With people, it's harder to control things. But ideally, this is what we do. And at the end of the experiment, any difference in the response variable can be attributed to the difference in groups, or to the difference between, I should say, between treatments. Okay, and so with a properly done controlled experiment, you can do you can make cause and effect conclusions. Okay, and so to assist in making sure that the two groups are identical as possible, we introduce things like blinding and placebo, because we don't want one group to know that they're getting the drug and the other group to know that they're not getting the drug. Okay, because that is a difference in of itself. So we introduce these things like blinding and placebos and stuff like that. And those are all just tools for controlled experiments. We wouldn't use blinding or placebos for an observational study, right? Because why would you? We're just letting people do what they want to do. Okay? Are there any questions? So this week, do your reading as is assigned in the course website. Do the homework problems. Take the practice quiz, and we'll see you guys next week. Make sure you guys get here on time. If you arrive late and the quiz ends at a certain time, you're not going to get extra time for the quiz. Okay, so make sure you get here on time for the quiz. Yes, we have a question. It's on the course webpage. Okay.